Alright, welcome to Chapter 10 review. Let's take a look. This is that circle chapter. Everybody's favorite, right? So, let's see. We said this side was 9, or 12. I'm sorry, that side is 9. And we said this is a right triangle, so that must be a quadrilateral, or a rectangle. Excuse me. It says find the exact circumference. So we're looking for the circumference of the circle, and it says exact. So I don't want a decimal approximation. I want exactly. Well, what is the circumference of a circle? Circumference is, you could look at it two ways. You could say 2 pi r, or you could say it's pi times the diameter. So what can we're set up right here to actually find the diameter. From this point to this point would be the diameter. If you could do Pythagorean theorem, that would work. Or you could recognize this. Look, this is 12 and 9 and 12. What's a common factor with this? Well, 3 is. 3 goes into this 3 times. 3 goes into this 4 times. So really this is a 3, 4, what? 5, right? 3, 4, 5 triangle. But that 3 and that 4 is being multiplied by 3. So we have to take that 5, multiply it by 3 as well. And that's a 15. You can do Pythagorean theorem if you wanted to. I just think it's a lot easier. Recognizing it's actually a 3, 4, 5. It reduces to a 3, 4, 5 triangle. So that's the diameter. Look, we're practically done. Circumference is what? You don't have to go 2 pi r. Use this one, pi times the diameter. So you could just say it's 15 pi. Do I plug it in a calculator and get a decimal number? Of course not, because it says find the exact answer. That is the exact answer. No decimals required on this. Okay, this is number 2 on the test. And here's our triangle. This side right here is 3. This side right here is 3. And we're trying to, again, find the circumference of the circle. Same question as they ask for number 1. So what is the circumference of this circle? Again, pi times the diameter. Look, it's set up for you to find the diameter. This is a right triangle. They do tell you that's a right triangle. These two sides are equal to each other, so it's a 45, 45, 90 triangle. Do we remember the relationship? Now again, you could do Pythagorean theorem, that would be fine, but it's a lot quicker to realize it's 45, 45, and you know what the relationship. Remember, the hypotenuse is the square root of 2 times one of the sides. So one of the sides is 3, the hypotenuse is 3 times the square root of 2. So that is that distance from here to here. That's the diameter, isn't it? It goes through the center, from one end of the circle to the other. That's the diameter, so all you have to do, it's 3 square root of 2 times pi. Remember pi d, pi times the diameter. That's the diameter, that's pi. Write it like this, that's an exact answer. It's no decimal approximation. You can leave it just like that. That's the easiest way to do it. Now if you did Pythagorean theorem, you might have come out to like the square root of 8, not like the square root of 18, you would have come out exactly the square root of 18. Or if you did it in a calculator, you might get a decimal. But again, we want exact. All right, on these problems, if it says find the exact, then find the exact. Don't put this in a calculator and get a decimal. You could have written it like this. I would accept that. Technically, that's not simplified, but it is the right answer, and it is exact. So we're good the way it is. Okay, let's move on to number 3 and 4. Same pictures. Number 5 is 2. We'll write down number 5 a little bit later. Let's mark the stuff on this picture, what they tell us. QRS is 40 degrees. And let me put this in a different color. Angle QRS. QRS is right there, and that is 40 degrees. And SRT is 90 degrees. And we'll put a little right angle to show that's 90. First question says find arc XQ. Well, arc XQ goes from here to, here. You get the idea. And that's what we want to find. Remember, these are central angles. The central angle is equal to the arc that it cuts off. So if I find this angle right here, XRQ, then I know this arc is going to be the exact same measure. So how do we do that? Well, they give this as 40 degrees. From here to here is 180. So it's 180 minus 40. 180 minus 40 is 140. So if this angle is 140, this arc right here is going to be 140 as well. So arc XQ is 140 degrees. Let's look at this. Let's find, same information, find arc VSX. Yeah, say that fast. VSX. Okay. Arc VSX. From here all the way around to here. So it's everything but this little bit. Alright, did you follow me on that? So I'm going to try to make it a little thicker. I doubt I'll be able to hang on the line. So we're finding this big old, oops, that's good enough. We're trying to find that big old arc right there. So really what we want to do is we want to find this angle. Can we find that angle? Sure we can. Look at this. Here's two lines. They intersect each other, so the vertical angles are equal. So if this is 40 degrees, then this is 40 degrees. So that means this little arc right here is 40 degrees. Now that's not my answer, okay? But what it is, it's the whole circle except for this. So a whole circle is 360, right? Except for that 40, take it away, so we subtract it, and that's just 320. So this arc VSX, VSX is 320 degrees. Alright, this is the same information. I erased a bunch of stuff. I probably need to put it back in there. But it says if XS, that's a line segment, the length of a line segment, XS. So that means the diameter, basically, is 16, right? So the whole thing from here to here is 16. That's the diameter. Find the arc length of XQ. So XQ would be this arc right here. Okay, so that's what we're trying to find. We're trying to find the length, not the angle, or not the degree measure of this thing. We're trying to find the actual length of it. Now remember, this is part of a circle. It's not a whole circle. How would we find the distance around the whole entire circle? That would be circumference. This is only a portion of the circle. Remember, this is 40 degrees, so this arc, or this angle right here, is 140 degrees, which makes the arc 140 degrees. We talked about that earlier. So what we have is not all 360 degrees, we only have a bit of it. We only have 140 degrees. We have 140 degrees out of, so you put divide, out of what? A total of 360 degrees. That's our fractional part of the circle. So we're finding the fractional part of the circumference. So what's the circumference? It's pi times diameter. So it's pi times the diameter. What did they just give you? That XS is the diameter, and it's 16. So you're going to chuck all that in your calculator, and you'll come out to approximately 19.5. It doesn't come exactly that, but we round it to one decimal place to a tenth, and then that would be our answer right there. So plug that in the calculator, use the pi button in the calculator, and you should get, rounded anyway, you should get 19.5. Okay, this is number 6. And it says find the measure of ON. I don't have anything labeled, so that's going to be ON. This is M, and this is L. And they tell you that this is a right angle. And it says find the measure of ON. I don't know, let's call it X. If OM is 6, so we mark that as 6, and LN is 16. So the whole entire thing from here to here is 16. Well, what do we know about this situation? We know, let's see, how do we want to say this? We know, alright, I had to find the theorem because I forgot it off the top of my head, but it says if a diameter or radius of a circle is perpendicular to a chord, which it is right here, this is a radius, or if it continued, it would be a diameter. If it's perpendicular to this chord, which is LN, then it bisects the chord and the arc. So if this kept on going through, it would bisect the arc as well. But I just wanted to find where that theorem was. I knew that it existed, I just couldn't remember exactly what it said. So it bisects it, and that's the key here. They tell you that LN is 16. They tell you that LN is 16. So in this situation right here, it bisects this chord. So this must be 8, and this must be 8 as well, however you want to write it. So if you look at this, this is now a 3, 4, 5 triangle. Do you see it? 2 is in common factor with both of these. So it's 3 times 2 is 6, 4 times 2 is 8, so what? 5 times 2 is 10. You can just do that very easily if you understand that it's a 3, 4, 5 triangle. If you didn't recognize it was a 3, 4, 5, you could have always done Pythagorean theorem. It would still work out to 10. Alright, but that's the theorem that you needed to know, that the radius, if it hits a chord perpendicular, then it bisects that chord. Alright, let's take a look at this one. This is 7 and 8. Here's the information that's given to you. It's an inscribed quadrilateral, and I wrote in the angles that they told us. And it says find GHI, angle GHI. GHI, so it's this one right here is what we're trying to solve for. So what we need to do is solve for X. Inscribed quadrilaterals, the angles that are opposite each other are supplementary. So we add them up. Plus 2x equals 180. That's 4x equals 170 when I subtract the 10. And when you divide by 4, x is 42.5. Oops. Double it, and you got that angle. So that angle right there, angle GHI, is 85 degrees. I'm running out of time. Let me just do the math, and I'll just show you real quick. Alright, I think that's enough. I found 2x, which is 85. 2x minus 10, so it's 85 minus 10, which is 75. 2x plus 10, which is 85 plus 10, which is 95. So if I take 360 and take all three of those away from it, I got this to be 105. But the question says, what is arc JGH? This one right here. This is an inscribed angle. It's double this, so that arc is 210 degrees.